All right, here goes a shot at this. I'm using an external microphone to get this taken care of, but this happens to be the practice test that I promised you I would make a video about, guys. So here goes nothing. Let's talk about this very first one. So it says the terminal side of an angle that's 243 degrees is definitely wound way too much. So what we're going to end up doing is we're going to take that idea of 2,430, and what I'm going to do right out of the gate is I'm going to take all the revolutions out of it of 360. So let's see what we actually got here. 2430 divided by 360 is going to give me a total of 6 revolutions. Now, what I'm doing with that 6.75 revolutions is that ultimately, if I think about that being 6 revolutions, I can take the 6 out, or I can almost think that the leftover revolutions have something to do with this 0.75 of an extra revolution that's on there. So that extra 0.75 revolution, I could think about multiplying that by 360, and that would give me an angle of 270 degrees. And 270 happens to be on the quadrant. So ultimately, 270 would be straight down. It's not in first, third, fourth, or first. It's none. It's quadrantial. There's your answer for the very first one. Okay? Second question, what's an angle of negative 3 pi over 4? What's its coterminal with? So I'm going to end up taking negative 3 pi over 4, and what I'm going to add to it is I'm going to add a full revolution, which is 8 pi over 4, and ultimately that'll put me at 5 pi over 4 is where that location is, and that should be your letter D. Okay? So again, watch that they want to write the answers in positive radians. Okay? Now, let me see if I can make this scale down. Oh, look at that. I did it with my fingers. Okay. Number 3, how many radians is the central angle that intercepts an arc length, which is S, of 84 inches and has a radius of 55 inches, okay? Couple of formulas you're going to make sure you got to watch for on this test, and that is S is equal to R theta. This is about arc length and radius. You're going to also want to look out for, and they use W, but we can use lambda just as easy. Lambda is equal to theta divided by time. That's angular velocity. And then there's also linear velocity, which is V equals R lambda, or V equals RW. And that's linear velocity. So this one's angular velocity. This one's linear velocity. Keep those in mind, okay? So in this question, they just want to find the central angle, which is the angle size. They've given you the arc length as 84, so 84 is equal to the radius times theta, which is 55 theta, and then ultimately all you end up doing is dividing these two individual answers, which is 84 divided by 55, and you should get an answer of 84 divided by 55. Should be an answer of 1.527 radians. There you go, number 3. An angle of 23 pi over 5, how many degrees is that? If you're trying to change something from radians to degrees, there's converters for it. Remember, you're trying to get the pi out of it, so you're going to want to multiply it by 180 divided by pi. Now, you're trying to get the pi's to cancel, and ultimately, it's top times top, 23 times 180. Take that answer, divide it by 5, and we should get an answer of 828 degrees. There you go, letter D. Okay? All right. Number 5, reference angle. Reference angles, remember, are always positive, and they are always less than 90 degrees. So they're small positive angles that's going on there. The nice part about unit circle ones is that we will be talking about definitely a pi over 6 concept that's going on there. And in that particular case, I would even take out all the actual radian amount. You can do this if you really want to. And that would be, I'm going to take out the full revolution, which is 12 pi over 6. That's 2 pi. That's 5 pi over 6, which is definitely in the second quadrant. And if I was to measure that in the second quadrant, the reference angle would be a pi over 6 reference angle. which is 30 degrees, okay? Sine of an angle is the following, period. Now, the problem here is you don't even have any kind of a picture of what you're dealing with, okay? And I'm going to say here that this is about sine. Cosecant is actually about talking about 1 over sine. Or better yet, the idea of it being flipped over. So if I actually took the 3 root 2 divided by 8 and I flipped it over and wrote it like that, now that's what the cosecant is actually going to be equivalent to. Now that's a problem because we need to rationalize that with the square root of 2 both top and bottom, and we'll end up with 8 root 2 divided by 6, which reduces to 4 root 2 divided by 3, and I believe that is not one of the answers that's listed there, so the right answer would be none. Okay, I'm thinking I did that right. Looking good, G. All right, number 7. Sine is 2/3 in the first quadrant. Draw it. Draw something in the first quadrant and make the sign 2 and 3 because it's opposite over hypotenuse. Now that is a dead giveaway. You're going to probably have to use Pythagorean theorem. 2 squared plus b squared is equal to 3 squared. 9 subtract 4 means that b is going to be the square root of 5. Okay? And since all of these are going in positive directions, you can leave it like that. Now the tangent of that picture would be the opposite divided by the adjacent, and that answer would be 2 divided by the square root of 5, which is rationalized to 2 square root 5 over 5. And that answer is letter D. Okay? Now, I saw a lot of people struggling with this part on the actual non-calculator part and have forgotten what the actual Pythagorean identity is. Okay? The Pythagorean identity comes specifically from that idea of x squared plus y squared is equal to 1, right? And instead of calling it x, we call it cosine, and instead of y, we call it sine. And guys, that is the Pythagorean identity right there, okay? So please watch out for that. Please know it. It is definitely something you're going to use in this class, okay? Cosine is 5/13, and sine is positive. Now, the real question here is you know that cosine is positive and sine is positive, so the place where that actually should be drawn is in the first quadrant, because that's where both of them will be positive. Cosine is 5/13, or adjacent over hypotenuse, and that would make this one 12, because that's a Pythagorean triple. You can check it if you want to use Pythagorean on it. That's totally fine. Now I've got a picture. What's the cotangent of that? Cotangent is x over y, or the adjacent over the opposite, and the adjacent over the opposite would be 5 over 12, and that answer happens to be B, okay? Number 10, I don't know where that is, so I should draw it. -1 and +4 would be somewhere in the second quadrant, and if I draw it like that, -1 and +4, Pythagorean theorem is going to give me that this coordinate, or this length of the hypotenuse, is 16 plus 1, or the square root of 17. And now it says, can you find cosine of that particular deal? And cosine would be the adjacent, -1, divided by the square root of 17. And if I rationalize that, I'll end up getting negative square root of 17 divided by 17. And that answer is letter A. Okay, we're cooking, guys. We're cooking with cooking. Where is tangent positive and cosine negative? Well, that location would be drawn as tangent's positive in the first and the third, but cosine is definitely negative in the third. So I would draw my triangle in the third quadrant with tangent being 3. Now this is where it's a little tricky because they say that it's positive, but it's actually technically a negative divided by a negative on this. I don't know why that's there. Go away. I don't want you. Okay. I don't know how to make it go away. Go away. Okay. And ultimately, Pythagorean theorem would make this 25 and 9, which would end up being the square root of 34. That's what's going on there. Now, if I wanted to find the sign of that picture is the opposite, which is -5, divided by the square root of 34, which is the hypotenuse. And that answer would be -5 square root 34 divided by 34. And that answer is not there. 11. Did I get that right? -3. Why is it saying? I like the opposite. Opposite over. I got those backwards, guys. This is backwards. Tangent is about the opposite over the adjacent. Make sure you fix this. -3 over -5. It won't change the actual deal there, but it does change this piece. Sorry, I'll fix this. I'm glad I checked my answers to see what's going on. The sign would be -3 divided by the square root of 34. And that answer would be -3 square root 34 divided by 34. And that happens to be the answer C. Okay? I'm hoping I got all the rest of them right. You guys tell me tomorrow if I'm screwing up anything. Quadrant 3. I think that's what that says. Boy, that is really hard to tell what that's saying. So in quadrant 3, what would actually happen? So in quadrant 3, adults shouldn't touch children. Tangent would be positive, which happens to be one of these ones that's listed right here, and that's the only one that says a tangent's positive. Cosine and sine would both be negative. 12 should be A. Yeah, I got that one right. Okay, so watch your ASTC. Okay, now go into the back. Here's what I want to first say. Multiple choice on the front end. Please just make sure you know how all those questions are done. Rewatch them if you absolutely have to. It is well within the deal, okay? 13 and 14 are all about changing things to different concepts. If it's in radians and it wants to go to degrees, or if it's in degrees and it wants to go to radians. The converter for this one, if something is in radians, you want the radians out. So you end up multiplying by 180 over pi. If you have something that's in degrees, you want the degrees out, so put the degrees on the bottom and put the radians in. And pretty much these questions are all about calculator work at this point in time. So on this one, 6 times 180 would be this divided by pi. And I don't know what it has as, because I'm trying to change it to degrees. Okay, so I guess divide by pi, and that answer should be 343.7. 343.7 degrees, done. Okay, next one, 155, -55 times pi, or really what we're going to just do is multiply it or divide it by 180. And then we're going to change it to a fraction, math frac that, and we'll end up with an answer of -11 pi over, and I think it was 36. Yeah, it was 36. There's your two answers for that. Okay? Moving down. Know those converters for 13 and 14. They're something you should know. Arc length. Arc length, dead giveaway, S. Radius, R. Definitely looking for a central angle, and it says, and the central angle is 3 pi over 4. S is equal to the radius of 15 inches times 3 pi over 4, and the answer here would be 15 times 3 divided by 4, and 15 times 3 is what, 45? 45 pi divided by 4 inches is what this will boil down to. Now, that's the reason why it's just inches is because the radius has got a unit, but the radian does not. That's why it turns out that way. Okay? Number 16, find the central angle. If the arc length, here we go again, arc length S is 30, the radius R is 20, find the answer in radians. 30 is equal to 12 times theta. Theta is just going to end up being 30 divided by 12. And that answer is going to be in radians. So that answer would be 30 divided by 12 would give you an answer of 2.5 radians. That's number 16. Okay? All right? Carousel is traveling at 12 revolutions per minute. I'm just going to pause right there and say 12 revolutions per minute has got something to do with angular velocity. But the problem with that angular velocity is that angular velocity is about theta divided by time, and we've got a problem. That's not in theta, that's revolutions. So I'm going to take 2 times 2 pi over the time is 1 minute, and I'll end up having something like 4 pi's per minute is really what we're talking about, and that'd be the angular velocity. Angle over time, okay? Shahida is on a carousel in problem 17. What's her linear velocity? Linear velocity is about v, and if she is going to sit 20 feet from the center of the rotation, that's going to be lambda, or angular velocity, times the radius, or r lambda. This answer would end up being something like 20, nope, we're going to do 4 pi per minute times the actual radius, which is 20 feet, and we will end up with 80 pi, that's 80 pi feet per minute is what her linear velocity will be, okay? A lot of those are really easy, guys. You just need to know those 3 formulas. S is equal to r theta, lambda is equal to theta over t, and the linear velocity is v equals lambda r. 19, find the positive coterminal angle. Make sure you read these carefully. Positive coterminal angle for negative 120. Well, if I think about negative 120 being drawn the wrong way, this is what negative 120 looks like. What's the positive way to get there? Well, we're going to be 60 shy on the end right here. So I'll add 60 to 180, and the answer would be 240 degrees. That's the answer for 19. Okay, sorry that looks funky. My 4s are all dragged out, sorry. And number 20, find the length in figure 1. Okay, this is all SOHCAHTOA work down here at the bottom, because the angles are not in the unit circle, so we have to think of this as our point of view. This is the opposite, this is the hypotenuse, and we're going to use a SOHCAHTOA question, which is a sine question. Sine of the angle, which is 26 degrees, is equal to 15 divided by W. This is a switcher case, where you would switch the actual W and the sine 26 to solve, and it'd be like W is equal to 15 divided by sine of 26. Okay, and off to your calculator for this one. Please make sure your mode's in degrees when you do this. 15 divided by sine of 26, and my answer should be 34.2 is how long that side is. Nice job. Okay, centimeters. I want to make sure I pay attention to that, otherwise Shulroy will get all upset. His butt hurt. Okay, number 21, finding the actual angle. Again, an opposite divided and an adjacent. This is a tangent question, and tangent of theta would be equivalent to 5 divided by 9. This one's going to be solved using the inverse. Theta is going to equal the tan inverse of 5/9. Again, making sure your calculator is in degrees. Inverse tangent of 5 divided by 9, answer 29.05 degrees. Done. Okay. 22, exact value of the following. This is all unit circle stuff. Tan of pi over 4 is 1. Sine of pi over 2 is 1. And cosine of 0 is 1. Answer is 3. Okay. Reference angles, let's remember that they are small. So 340 degrees is definitely over here in the third quadrant. What's the reference angle that I'm going to need to actually know to get there? Well, I'm going to take it away from 360. 360 minus 344. And, you know, my brain doesn't want to work that hard. 360 minus 344, answer is a 16-degree angle for the reference angle. Okay? References when it comes to radians, just make sure that you have rotated the whole thing out. I don't think you even have to worry about the actual deal. My gut instinct is telling me that that's pi over 3, but I'm just going to check it just to make sure. If I take out all the revolutions that I can, I would definitely subtract out 6 pi over 3s, which is 6 pi over 3 is a 2 pi, but there are several iterations of that, like 18 pi over 3, that's actually 6 pi, that's 3 revolutions. I take that away from there and I'd end up with 4 pi over 3, which is definitely in the third quadrant, and the angle of reference would be a pi over 3. So that's why it's kind of nice to do radian ones, okay? What quadrant would W lie on if cosecant was negative? That's really actually saying sine is actually negative. Sine of W is negative. So sine is negative. I'm going to put that's negative. Which would ultimately be in quadrants 3 and 4. So this guy right here is giving you a 3 and a 4 quadrant deal. But when cotangent is negative, that's negative again. Cotangent is negative in the second and the fourth, and ultimately the thing they have in common is the fourth quadrant. That's where it would actually be drawn. Okay? Now, the bonuses that are down here at the bottom, let me take a look. Let me see if I can get my brain wrapped around it. A line with the following equation, an angle lies on that line, its terminal in the third quadrant. Okay, so I'm thinking maybe this line, since it crosses the y-intercept at 0, it has a slope of 4, and I know it's going to make a triangle out here. And the real question is how much does it rise and how much does it run? So this is the rise idea, and this is the run idea, which are going to give us dimensions in the third quadrant. Boy, I drew all that wrong. It's in the third, gee, not the second. So if I draw it in the third, like this, like it should be, this is the triangle, this is the run piece, and this is the rise piece right here. And I bet you that's got something to do with the slope. And as soon as you get that slope, I bet you'll be able to figure out what's going on. Okay? The second bonus, I'm not giving that one away because you should really be able to think about that and pull it off. Here's the coordinate -5, 6. In this one, I draw the actual deal down and go that this is 5 and this is 6. And I'm sure I'm probably going to have to find the hypotenuse. And then it says, what's the length of the arc from point A to point B to the nearest tenth? Well, here's the deal. You're going to have to probably come up with this dimension, which is the radius of a circle. And this part right here is going to be 1/4 of the circumference of the circle. And then you're going to want to add on a certain number of degrees of circumference there, and you'll get the total arc length. Or better yet, maybe you could just come up with this theta right here and use S is equal to R theta. Ooh, I'm giving you some insight. Try that question out. That's why it's an extra credit. Okay? I hope that helps you guys out. I'll see you guys tomorrow.